Today we're going to be talking about the integrated rate laws and the half-lives and some problems to do associated with them. So these are the integrated rate laws. They're on your AP chemistry sheet, so you don't need to memorize them. But notice how these all look very similar to the basic form of y equals mx plus b, which is the basic format for a linear equation. Here, the y's are all different. For a 0th order overall reaction, the y is just a, or a at t. For a first order, it's ln a, and a second order is 1 over a. For each of these slopes, the slope is always k. You see x is t, like our independent variable is time. Our slope, or m, is k. Notice how for 0th order and first order, it's negative k. So both of these has negative slopes. The only one with a positive slope is second order. So if we look at the graphs for each of these, the 0th order is going to have the x-axis is always time, but the y-axis is going to be just a, where a, by the way, is the concentration of the reactant, and it's going to have a negative slope, just like that. For a first order, it's going to be, again, t at the x-axis, but it's going to be ln a, and it's again going to have a negative slope. For a second order, it's going to be 1 over a, and t on the x-axis, and it's the only one with a positive slope. So if the test shows you this graph and asks you what order is the reaction, it's second order. Or if it says what graph is going to be linear for first order, one of the options has to be ln a, or ln reactant. So those are the integrated rate laws. So a half-life is how long it takes for half of the concentration of the reactant to get used up. So if I have 10 molecules of A, for the reaction to use up 5 molecules of A, it's going to take like 10 seconds. So 10 seconds would be the half-life. So to my left, I have all the half-life formulas for 0th order, first order, second order. You can either commit these to memory, or I'll show you in the next few minutes how to derive them. So if you just want to commit these to memory, you can skip the next few minutes. But to derive them, all you do is set a of t equal to one half of your initial in your integrated rate law. So these are given on your sheet. If you just set a of t equal to 1/2 a0, we could derive all the half-lives. So for 0th order, we'll set 1/2 a0 on this side. We could subtract a0 on both sides, and then we'll end up with negative 1/2 of a0 equals negative kt. And then if we divide negative k on both sides, we'll get a0 over 2k equals t. So all you do to derive the half-life is you set a of t equal to 1/2 a naught, and then solve for t. So that's our half-life of 0th order. For first order, we got ln 1/2 a naught equals this. So all you're going to do is subtract this on both sides. So it'll be ln of 1/2 a naught minus ln a naught equals negative kt. Notice by log laws, we're able to do ln, you subtract log of something minus log of another thing is the same thing as log of this divided by this. So it'll be 1/2 a naught over a. Notice how these a naughts cancel. So it's just going to be ln of 1/2 equals negative kt. If you multiply the negative on both sides, it will, instead of ln 1/2, it will be ln 2, because it just takes the reciprocal, equals kt. So that means t equals ln 2 over k. This one's kind of tricky with the log laws, and this is the easiest to memorize, so I would just know this off the top of my head. And then for second order, we set it equal to 1/2 a naught. We can subtract. This is the same thing as 2 over a naught equals kt plus 1 over a naught. So if we subtract this term on both sides, we're going to get 1 over a0 equals kt. Divide by k on both sides, you get t equals 1 over A0K. So that's how to derive your half-lives. That's just in case you forget it, but you really should know them off the top of your head, and with some more practice, it'll be easier. So now we're going to do some practice problems and see how we can apply these rate laws.